Okay, here we are. Let's quickly double check if everything worked out. So we should be live now. I hope everything is working. You can see the stream also. Announce it on Blue Sky. So I would say we are live. That's pretty cool. Yeah, welcome to today's stream. Very happy to do it today because this will be a really fun one. It is not necessarily a productive one; it's a fun one. So that's a cool thing on today's stream. So what we want to do is talking or trying actually to put the user interface I've built with Solid.js and convert it actually to Leptos, which is very much the same framework as Solid.js, just written in Rust. And yeah, let's just do that. But before we're actually gonna start with that, let's quickly walk through something else. And that's actually one thing that has changed in the last week is that I've set up a public roadmap actually for my Cozy Coder project. So if you don't know about my Cozy Coder project, feel free to go here to cozycoder.dev and you find a little bit of information. So this is about a coding space with AI. So yet another AI tool, of course, out there. I have created a public roadmap, so there's a little bit of functionality. So what you see here right now is basically what I want to get done for a very first, let's say, alpha release that I will hopefully then put out as also pre-built binaries that everyone can just install, and from where we can then continue iterating and adding features and polishing the user interface and doing all the cool stuff. So yeah, that's actually the roadmap. You see one little part is already done. This one is almost done, and yeah, there will be other stuff coming. So let's quickly jump into the code. So what has changed since the last time is that I can just start actually the application with cargo Tauri dev. And what you can see is actually that the user interface now does something. So last time we had already a single chat, so there was already some chat data in it. This is all just static data that has been generated by AI as test data. We can also type in something here and see that the assistant responds with some dummy response that is actually nothing. So this is just fake data and fake responses right now. So the backend doesn't have any functionality, but it provides some little user interface here. This is probably not the final one, but it's at least some user interface, as you can see. And we'll see where this actually will go over time. So at least you can see that you can do something with it. You can create a new chat as well, and then type something in here. Yeah, that's basically it. So a very basic chat interface with a dummy backend that is faking all the stuff. And you can also delete things here, which doesn't make any sense right now because it's just in memory. So you restart the app and this initial food chat here will just appear again, and this will always disappear. So as I said, just dummy data, but at least you can see something. And if we look into the code base here, what we have is a couple of files actually, and you can, let's see if I can make this a little bit bigger. Yeah, that's much better. So of course we have here an index HTML that just loads the stuff, and we have some package JSON here with some dependencies. But that's not really the cool part. The interesting thing is actually here in the source directory. What you can see is there is this this app this app TypeScript file, which is basically the main application. And last time we did everything here, but now I have refactored this a little bit. And to be honest, I haven't done it myself. I asked Claude to do most of the work here, which worked surprisingly well, to be honest. But we will come to that later. So what we have here in this case, as you can see here, is we have this app component, which basically doesn't do anything else than showing a chat list. This is actually the sidebar that you can see on the side, on the left side, and it shows actually the list of chats. When the component is mounted, we initially call the refetch chats, which is provided by the API, whatever this refresh chats does. We will see this also in a second. And then it shows some children here. And if you look here down in this index.tsx file, you see that we are using a router. So basically what happens is that whenever we select a chat from this list, a URL is called, which is basically /chat/ and then some ID for that particular chat. And then that particular chat is shown in the chat view, component here. And interestingly, initially we just launched the root component, or let's say the empty state component, and the app component itself is now the root component. So this is a different kind of thing. So the root path actually shows the empty state on the right side, and the root component for our application actually is the app. And this is this one component that we already saw. So this basically acts as a layout. So the chat view or the empty state component will basically be rendered here as a children. When we look here in the components, so we have several components now. The empty state is rather a simple one, where we have just well, a little text to say start a new conversation, and then we have this message input. We have also this chat view, which does a little bit more. So it actually, let's go down here. So this chat view actually shows a list of messages. Then we have this message component to render the concrete message. And we also have the message input here at the bottom that we use to enter the message. So this chat list itself is also rather simple. We just render a list of chats. It just shows, I think the most difficult part here is just the CSS stuff that is done. And when we see at the message, that's just showing some HTML. So no logic being involved here. It's just rendering. I moved this into a separate component, or let this move by Claude, mainly because of keeping the chat view a little bit lighter from a code perspective. And then there is this message input component here that basically handles the submit with disabling the send button while it's sending in the background. And we clear the UI when things have been sent, and there is some input value that is stored in the background. And then when we submit this, this button is disabled until it's submitted, and we will send it somewhere. So there is an onSubmit function being provided as as an attribute, and then each component can define itself what to do. So this is basically the user interface that you just have seen. That's basically the code behind it. It's mostly AI generated by Cloud 3.7 Sonnet, and this is all using the Solid.js stuff. So we have JSX here with the HTML being embedded in the JavaScript, and we are using here Solid.js for creating signals and the hooks and all the stuff, because it's quite fast to do that and quite lightweight compared to React, which comes with a virtual DOM, which is way more complicated. We covered this all in a previous stream already, so let's not repeat all of this. But one thing that, and of course we also interact with the backend. So we have a messages API, which basically calls here the invoke function from the Tauri core API. So Tauri is a framework for building desktop applications with web technologies, and we use that to call some backend functionality. So there is a send message and a get chat history function written in Rust that is then called. So we can also quickly look this up. So here is the Rust backend. There's, as you see, some static data that is generated, and then we have, for example, here a send message function that is invoked through this API, and it basically creates a user message, adds it here to the chats list in the history, the fake history that we keep here in memory, and returns it that, and returns actually the message. This is not exactly how the API should look like. We have to refactor this still, but it's not really the thing that I want to do today. So what we want to do today is we have this little directory here, this source directory with all the TypeScript files in, and we want to basically convert this to Rust, because as we write the backend in Rust, why not also writing the frontend in Rust? You know, the idea is actually, is it possible to have something like, let's say, like a front end, a full stack Rust application actually. That's roughly the idea where we want to go, and we want to see if this is possible or if this is feasible in a simpler way. So the question is how to get there. And what we will not do is to just change the code here. What we will do instead is we will actually create a new application for that. So we will use cargo. How was it called? Tauri. Create Tauri. Yeah, that's exactly the thing we want to call. So how do we want to call it? We want to call it the Cozy Coda. Let's call it Cozy Coda RS. It's just a code name. We just want to see it working. We don't want to really commit this today. It's a proof of concept, so we will decide then later if we want to do something with it or not. Yeah, the identifier doesn't matter that much. It is based on Rust. We will use the Leptos framework, and oh, that's all. We have it already running. So let's and we see also that there is a little bit of information. So it looks like we need to install cargo, that we need to install trunk, which we will do in a second. So let's first go into, how did we call it? Cozy Coda. rs. Let's move into that directory, and let's actually use Miso to install it, because then we get a version specifically here, which is way more helpful. So let's do that. We need the Tauri CLI. Looks like we also need trunk, whatever trunk actually is. As far as I know, trunk is kind of a bundling tool for Leptos applications. I think it's not Leptos specific, but you can use it for Leptos. So the Leptos Rust code gets compiled to WebAssembly, and then you need to actually get the WebAssembly and the CSS and all the stuff being bundled together in a way that it gets loaded in the single page application that we want to create. And I think also the development server for that. So in the Solid.js app, we used Vite for doing this, and I think trunk is the equivalent here for the Leptos application. So this might take us a few seconds here to compile until everything is ready. And while doing that, we can simply copy here the last command that we need, because we want to compile things to WebAssembly and run them in our web view. We of course also need the WebAssembly target in Rust. So let's wait until the installation by Cargo is done. Yeah, it takes just a few seconds, minutes. Let's hope it's done soon. We are already at 2 minutes. How long can it take? Dun, 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 dun. Yeah, installation sometimes takes time. So just to keep up on that, so the Leptos framework, while it's installing, let's quickly look into that. So if you don't know about Leptos, we talked in previous sessions already a lot about Solid.js and the way Solid.js is different compared to React.js, because it doesn't have a virtual DOM, for example. And the interesting thing is Leptos basically implements the same pattern with the fine-grained reactivity. So Leptos is a fine-grained reactive signals web framework. And this is pretty cool because it's just the same thing. The only difference is you use Rust instead of TypeScript, and you can compile it to WebAssembly instead of JavaScript in the end. And that's basically it. So we have here a counter button. We can and we can just click on the button and it will count up. So this example is a very simple one. So we have a button component here, similar to, well, in Rust we add a component macro here on top, and we have then the function that returns something that is implementing into view. Similar to JSX in TypeScript or in JavaScript, we have this view macro here in provided by Leptos, which will actually allow us to put just simply HTML into our Rust code, which is very nice. So very nice feature. We can then just similar to or in the same way that we do this actually in Solid.js, we can use functions here to call something, and if we have defined a signal that we are using within it, for example, we are using the set count here, or we're using the count here, what happens is that, especially for the count here that we use, because it's a signal, there will automatically be a subscription in the background for this. So what happens in the end is that whenever we call the set count to update the value, so as you can see, you have the set count reference here, and you call the update method on it, and the update method actually takes a function to update the value, and whenever this happens, there's automatically this code here is actually automatically updated because during the rendering there is a subscription happening in the background to the signal here. So that's why when you click here on the button, this function actually is executed here to take the number n and increase it by 1 to update the count. That's it. So nothing very special, just straightforward Rust code. This compiles then to WebAssembly and runs within the application. So now we are done with installing trunk, and now we can also set up the button target to being able to compile to WebAssembly. So this is also in place, which is pretty nice. Let's just ensure we are on the latest here. So the next thing should just be that we can run cargo Tauri dev. This is exactly what we run in the Solid.js case as well. So let's just give it a try. If everything works out, everything should just work. So you see that we are starting trunk in the background. It's compiling a lot of Rust code. I would assume that that using Rust here might slow down the compilation process a little bit, because TypeScript in the end is maybe compiling a little bit faster. Rust is known for its rather slow compiler, which of course is not because Rust is such a bad compiler, it's just because it's such a powerful compiler. I might expect this to slow down a little bit the compilation process during development, but that's something as a Rust developer you have to get used to. So that might still take a little bit of time. Let's quickly jump into the documentation here again on the laptop dev page. So your favorite language, that's actually the thing. The interesting thing is also for it is great for full stack components, which is here we are. Now it's definitely on the wrong thing. So this is the standard Tauri application. You have this in every web framework. So here you can enter a name and then click read, and then it does the job. So this is actually the web application. The interesting part here is that this string here is generated by Rust, but this user interface here that you see in the is actually HTML and CSS, but it is also generated by Rust running in WebAssembly. And that's basically it. So let's come back here to the favorite language. So there's also this server thing. So you can actually build full stack components, which means you can have components where you use this view macro here to use HTML and also define your own components here, like in JSX, or within Rust. And if you have then a server side as well, then you can, for example, say, okay, I have a server here for saving the favorites, is /API. And you can, where is it actually used? Here, there's the favorites action. So we have the save favorites server component here, and actually we can create a server action for save favorites, and then we can say, okay, we can have the value of this to fetch the data, and do something with it. So we can use actually this action here for the form and so on. So this is a seamless integration. When I remember correctly from the documentation, there's support for different backends. So you can use this with, if you're using Axum, for example, as a web framework. On the server side, there is some integration with Leptos if you want this server integration. So then this /API is provided somehow via Axum under the hood. And we can now enter something here like chocolate. And the favorite color is, I don't have a favorite color, to be honest. Let's say red. Well, Rust red. Is it really red for us? I don't know. Oh, here are some red chocolate cookies. That's a very nice idea. Okay, and as you can see, it's just simple Rust code. You have JSX-like syntax, server integration with your backend code. The server-side integration doesn't make that much sense for me personally, because in our case we have the Tauri application, and the Tauri application. Wait. Let's also get in it here. And the Tauri application will ensure that the backend, the Rust backend in the Tauri application actually can be accessed through these commands that we have seen earlier. And while this is fine, it is still not the same as doing an HTTP request, which is the thing that Leptos out of the box does. As I said, it works pretty much like Solid.js. So if we look here into the app.rs file, this is actually our Tauri application. And we have the main RS file, which contains our main function. So this is actually the entry point for the WebAssembly. So we have, again, like in every Tauri application, we have this source Tauri directory, and within that directory we have a main function here, or a main file here in the source Tauri directory, which doesn't do anything else than just calling the run function that is defined here by Tauri. It uses usually the builder to add some plugins, handlers, other stuff, and then launch the Tauri application. On the other hand, we now have a second main RS file, but this time in the source directory, so in the root source directory, which is actually the main function that gets compiled to WebAssembly and then launched within the within the browser. And what this one does is, as we can see here, it mounts to the body a view, a Leptos view, rendering this app component. And this app component is defined here in the app.rs file. So we have this app component here being defined. It does some nice stuff here. Yeah, that's basically it. We have some bindgen here, all standard stuff. There's a little bit of additional stuff like this HTML file. And this index.html. So what this basically does is it loads the CSS, the copy, the public the public directory, and it loads also our Rust code. So the important detail here is the data minus trunk, which tells actually trunk, the build tool here, that this file here is loaded, is actually CSS, or it is actually the content of a specific directory, in this case, the public directory that needs to be copied over. In the case of Rust, it will just compile this to WASM, to WebAssembly, and then use some optimization level here. And what's also interesting, if you wonder how to use, for example, Tailwind here in this case, Trunk also supports, instead of CSS, a relationship or a rel attribute Tailwind, and it will then call the Tailwind executable automatically on the fly to compile actually, or to create actually the Tailwind, or yeah, to execute Tailwind to create the correct CSS file and load it here. This is a configuration for Trunk, nothing we need to care about. It's very simple, straightforward Tauri application. We can have a quick look here in the CSS file, but that's just standard CSS as we get this from normal from normal Tauri application. So very much the same as we had in the early beginning when we generated an application with Solid.js. So what do we want to do with that? Well, the obvious simplest approach to get something done here is we will just throw this into Claude and see what comes out. So I have here a Cozy Coder front-end project in Claude, and I have actually added all the TypeScript code already. So now what we can do actually is we can add our Rust code as well. So if we add the Rust code, we can now ask Claude to do something. Maybe this works better. I didn't try this up front, so let's see how good this will become. But I'm very much convinced that this is a good idea as a starting point. So let's see. Claude has surprised me recently a couple of times. So what do we want to do? We want please convert the chat UI application from TypeScript to Rust. TypeScript and Solid.js to Rust and Leptos. Use the existing main.rs dot app.rs files and extend them. Let's see what happens. So now let's wait. Claude is now thinking, obviously. I like actually that you can look into how it's thinking. So while it's thinking, and it might take a while until it's done with thinking, so we can actually see what it's doing. So it understands the current application, well, and it basically analyzes what the different parts of the different files are doing. The existing Rust Leptos files, its main RS, simple hello world style, application with greeting form. Yes, exactly. So it understood at least what it has as a foundation. So now it's, it should converts, it plans a structure, defines a data structure, implements a component equivalent to the Solid.js ones, and now it thinks about the Leptos components we'll need. A chat list, a message input. Yeah, it's pretty much the same. That's exactly what I would expect from it to do, that it creates exactly the same components. So this also means it should be very easy to translate the HTML from JSX to Leptos, to the Leptos view and stuff. And now it goes through it. So yeah, okay, that's easy. So it has the app RS. Here it adds a router with the corresponding routes. Actually, that's interesting because I hope this concept of routes exists actually in Leptos. We will figure this out. Because I'm not that familiar with Leptos yet, so I have no clue if all of this will be working. It's also for me pretty much the first time that I try this, especially in this way. So it creates here also structs for the chat, for the message. In the same way, it defines this API RS for fetching the chats. It invokes the commands here in the same way it should. So now we call from Rust the invoke, and this is actually something maybe to highlight here. If you want to call a Tauri command from which is actually itself implemented in Rust and compiled to native binaries, if you want to call this from the WebAssembly code here, what you have to do is you have to declare actually the invoke function as a native binding. It's an extern C, which is of course not really C, it's in this case JavaScript, but you have to make sure that the JavaScript function that is provided by the Tauri API is made available through a native binding here in Rust, and then you can just use that one and call the match function here, and then it goes on and goes on and goes on. So after, let's collapse this here again. So as we can see, after 3 minutes and 4 seconds, it's done with thinking. We could go on with reading through all of that. And now it just tells us a little bit of, I'll convert the chat UI application from Solid.js TypeScript. Here's the implementation. So we've chosen style contrast, so that should be quite small in response. I'm pretty sure I wouldn't have been able to write this all myself within 5 minutes. So it looks like 3 minutes of thinking and now a little bit of generation of code. So we will hopefully stay under 5 minutes and yeah, writing all of this code myself within 5 minutes. I don't think that I would have done that, especially with looking up all the APIs and stuff like that. but we still haven't seen if it works, and that's still to be done. So let's wait a bit. What we can already see is the files it created. Um, so still writing. Maybe it's a little bit more than 5 minutes. I don't know. But it should soon be done. It also tells us that we have to um, change the cargo tunnel, maybe. I don't know if it really means it, but at least it tells us that we could. Yeah, we need no Leptos, and the Leptos router might not be there. So let's start with doing that. Let's see. We start with the cargo. So what we can do here is, so the Leptos, that's there. Thousand point can. The futures. JSS is there. Yeah, that's obviously there as well. That's also there. And also the panic hook is there. So it looks like we had the same things before as well. um, and damn. And it tells us that there is a newer version. So let's use the newer version. Whatever. This. This. So what we have now, we can update the others later. Doesn't matter that much. But at least we have now the required dependencies. So let's go down. We will probably change this file here in a second. Now the Rust analyzers loading the dependencies. Let's quickly go through what Claude told us here. This implementation converts the Solid.js chat application to Leptos while maintaining the original functionality. Here's what I've created. Data models and API integration, core components, application structure, blah, blah, blah. Nice. So now let's quickly go through that. We have the models file here, which contains the chat and the messages. We have the API here that has this native binding to the invoke function from Tauri. We have this invoke command, a helper function here that allows us to call this in a nice way. We also have some serialization through Serde for create chat data and create chat arcs. Interesting. So we actually have some static typing here as well. Also here for the delete, we have the delete arcs. I wonder if we really need that, or if there's if we couldn't just provide some string there, but I think it's also fine to have it. And so we have the different APIs here. Then we have the message component that looks like a straightforward conversion. So we have here the properties being declared. We have the input message, the message input component here that does a little bit more. So we have an onSubmit callback. We have the placeholder, the container class, blah, blah, blah. All the stuff, the handling of the handle submit functionality that we originally had, and all the stuff. And we have the mod.rs file that we need here and the updated app.rs. So for the app.rs, what we do is we have the routes here, and in the main RS, what have we changed here? Interesting. It inlined the CSS, which is not really what happened in the original code base. So in the original code base, we had the CSS just in a style CSS, which is good enough, and we don't need that. So let's just ignore that part here. It mounts here the tailwind. Okay, let's remove that part also. Let's quickly go to its application structure. Okay, nice. So please remove tailwind and CSS from main OS, since it will be provided externally. So now it should only update the main RS file. Let's hope. And the rest should then be working. So now it is pretty much the same as we had before. We just mount the app component. We can just double check, and that's it. It's exactly the thing that we had before. So we don't have to do anything here. Let's do things with the other stuff. So as I said, the cargo terminal we already updated. There's a main RS file that's changed, so we have to start with the app. We will do it really in the most simplest way, which means that we will just download the code blindly from from the browser. Where can I create a directory? Components. I hope it was components. Yeah, it was. So in components, we want to call it just mod rs. Then we will take the empty state component. We will take the chat view. We have to fix that. The chat list. The message input. I don't understand why Claude gets this so fundamentally wrong. Oh, come on. Um, we will update this. So store this part. And now we also have the API. Goes directly into source, and we have the models. So let's quickly jump over. Um, and go into source. So that one. Let's go into components. And here we have to do a little bit of cleanup. So we have to move this to, oh, come on. Line goes for views. Line goes for empty state. And here we have even to remove the component. Because file naming matters. We all know that. Interestingly, it doesn't compile. Ah, the function app should have snake case. um, interesting complaint. Um, but this was already the case before. We didn't really change that. Isn't it? So to the app. Yeah, it was already called app. So why does it complain about that? I think that's an editor issue. We can fix that later. So we can still look this up somewhere. But let's run it. Oh no, it panicked. No. Couldn't recognize the current folder as a Tauri project. It must contain a Tauri conf JSON. Ah, yeah, damn. So you have to run it, of course, in the root, and then it will compile what it doesn't compile. Fail to select the version for Leptos router. Required by package is version. You look into. So that feature. Well then, doesn't have that feature. We can also remove that. If this is the only issue, we can just ignore it. that's too easy. Um, you can see here on the other side that the Rust analyzer is also heavily working um, to index all the new dependencies from Leptos, which makes a lot of sense. But yeah, so what you cannot see that well on the stream, but let's just make it visible. So there's nice little emojis here being provided. I think it's coming from Trunk or from Tauri, I don't know. So right now what happens is that so the way I understood this is okay, so this cozy coder as UI. Oh, it's still on that one. Okay. So this UI actually is the actual package that we build, the actual WebAssembly application, and then it compiles CodeCoder.rs, which is actually our Tauri application. So we have errors in the UI. Let's see what the errors are. Let's see. There is a Leptos. So see where what the documentation says. So the documentation says we should have a component. Well, that's what we have, the app. And we should have the view. That's also something we have. Um, that might be the property that we can declare a router and the routes. Okay, that's fine. Let's quickly then say doesn't look as I wanted. Missing required field fallback. It's been declared here. Let's just copy that one. I put it on the wrong place. Place. So, first thing. So what else? No method name child for found for struct letters HTML. That's an interesting compile error because I even don't know what it should mean. We wrap the whole app to. Okay, so the other difference is that they have created a div around the router. Let's see if this actually helps. Would be interesting if that was the reason. No, it's not. That's an interesting. There's also this path thing. So it looks at least that this is also not correct. This one. This imported here. Okay. Still the problem. Get the compiler once again. Let's see what code does. Get a compile error. Dear Cloud. So please tell me what's the reason. So now Claude is once again thinking. And it now has changed something. Did it? The error occurs because there's an extra diff wrapper. Oh, come on now. That's bullshit. That diff has been created by me. The error happened before. That's a bad joke. Place that compiler. The implementation. So now we have the corrected compiler without the diff. So it cannot tell us there's an extra diff around that. That's a very stupid answer. Okay, what do we get here? There are occurs because there's a syntax mismatch with your Leptos version. Let me update the FRS file to be compatible. Make sure your cargo terminal has a correct version of Leptos that matches what you're using in your project. Okay. So this was actually 0.5. I'm convinced that just upgrading was maybe not the very best idea. We wanted to get this code running, and upgrading is obviously a good thing for later. It's right. It's really just a breaking change introduced by a newer version of Leptos, because then it's something we can still fix at a later point in time. So, don't get anything. I know what we also did. We also changed actually the code here. We should maybe not do that. So data to a couple of things breaking. B. What? Things compile out. And again, we are thinking. The interesting thing is, I have the feeling that the Rust code that is generated here requires more iterations by Claude, while the TypeScript code that it generated before didn't have those compile errors in that way. So that works much smoother with TypeScript. But let's see. So let me fix the navigation issue. Okay. So it provides me an updated version of the chat list component. So let's replace that one. And it provides me an updated version of the empty state as well. Let's replace that one as well. So once again, let's see what happens now. The chat view. And we see what happens. Fix the error handling in the error boundary component. Yes, please do so. This was actually the chat view. Let's replace this one as well. Now we can again run Tauri dev. Oh my god, we have another compile error. From one to another. That's more than thinking. Yeah, my general impression is that LLMs are not as good as generating Rust code compared to other programming languages, especially TypeScript seems to be supported quite well. Um, Also, Python seems to work a lot better. Um, but that doesn't mean that it cannot do that. So let's not give up here. We want the AI write our code. You will get there. Come on. fix it ourselves. That was actually not the plan, but we will see. Still chat view, so the chat view, the chat list, and we have the empty state here. I think there's still some compile error left for us. Let's allow the LLM further iteration. The closure issue. Then I don't think that this is going in the right direction right now. I have the feeling that I'm actually not reading really what it does. It just changes something on the code, because I still hope that we can get something out here that just works. But it doesn't look like we are really on the right track. And yeah, let's actually see. So this was the chat list component and the chat views component. Okay, there are just two. Let's see. This one. Let's see what you're doing with that one. Tip: long chats cause you to reach your usage limits faster. Yeah, I know. I know. I'd like to start this here. I don't want to start a new one. Just let's see if you finally make it. Let's see if Cloud can finally make it and get a working version here. That would be actually what the most appreciated thing. And the really, really bad thing is that, what? Why does it generate all of this again? The really bad thing about this is we still have to update then the Leptos. I'm not really sure if this is good. Okay, let me fix it. Let's just download it again. Components, mods. Input. Code is actually much jealous. Writing code makes a lot more fun than seeing code actually failing, to be honest. I think we are done with Claude here, actually. Wait, what's going on here? I think this Claude thing doesn't work, at least not in this case. So, and I'm even not sure if I want to fix it myself. Yeah, so it doesn't look to me like a very good solution. Nevertheless, let's quickly go through some of the code here. So we have the chat list. I'm actually not really sure what it did now with all the code. And we know that it doesn't really fully compile. But okay, it has created a lot of stuff. In the end, we have this view thing. But yeah, I'm not convinced that this is the right direction. Yeah, so what to do with that? It's actually quite interesting because one of those things that I had in mind before I went into this experiment was I I have done mostly backend development over the last couple of years, and one of the really cool things about Claude especially is that Claude works extremely well in generating TypeScript code and in JSX. And that's pretty cool for me as a more backend focused engineer, because this makes Claude actually a good front-end engineer for me. I know enough HTML and CSS to basically let Claude become a front-end or take over the front-end engineering for me. So this allowed me actually to write not TypeScript, but let Claude just generate all the TypeScript. Even I didn't do the refactorings there. I told it, hey, please change this, please change that, and it did. And that worked extremely well. And while on the other hand, the idea of a full stack Rust application sounds like a very good idea, I think this only makes sense with investigating Leptos a little bit deeper and really learning how to write this in myself. Because what happens right now is a lot of compile errors with this generated code, and Claude isn't able to fix this. I think so. My experience with LLMs in general is that for Rust they are not as good as for others. So yeah, I think in the end the most important question will be: do I use Rust and do more things myself in the front end, or am I going and stick with TypeScript just because Claude is much better at generating it? I'm not really sure which direction I want to go. I will probably give this another experiment next time, maybe with doing the rewrite myself to learn more about Leptos actually and how things work. And maybe that gives me then a better impression if this is the direction I want to go. But yeah, it was actually interesting to see that at least Claude, after how long are we doing this? 1.5 hours. So even after 1.5 hours, Claude hasn't resolved the compile error, so we didn't have a working version. A simple translation was not possible. I think looking into rewriting it manually is a much better idea. That's it for today. The next stream, I hope I will do another stream this week. I'm not 100% sure if this will work out, but I hope I'll do another one this week. And yeah, then we will see what we're doing. And I wish you a nice rest of your day, a nice evening, a nice, yeah, and a good night, whatever the time is for you right now. And see you then maybe later this week in another stream here on YouTube. And feel free to follow me on Blue Sky as well if you want to get more updates on how